this section, we're going to talk about volume. Volume is the amount it takes to fill up an object. So it could be the amount of water, it could be the amount of sand, lots of different types of things that could fill up an object. We're going to continue focusing on polyhedra. So again, here are a couple of examples. We have prisms to start off with. A rectangular prism has all sides as rectangles. A triangular prism has all sides as rectangles except the two bases are triangles. Pentagonal prism has all sides as rectangles, and then the two bases are pentagons. So again, we need to know that bases are the two sides that are parallel to each other and have the same shape and same area. The height of a figure is the perpendicular distance between the two bases, just like with two-dimensional figures. So if we look at the triangular prism, the bases are the two triangles, and the height is the perpendicular distance between them. You can actually see the height in three places here. We have the height that I have drawn in, and we also have this height, and they're all the same. They're all perpendicular distance between the two bases. So all of those line segments. The formula for finding volume of any prism, any solid that has two bases parallel to each other, is the area of the base times the height. So that capital B actually means area of the base. So that for that capital B, you're going to find the area of the base. In this case, you'd find the area of the triangle, and then you'd multiply it times the height, this line right here. So let's look at an example. To find the volume of a prism, multiply the area of one of the bases by the height of the entire prism. So in this example, we know the area of this top base is 16, because this is a cube, so it's 4 times 4. So that area is 16, and then the height is 4. So when we multiply, we get 16 times 4, which is 64. That's our volume. Now, we're working in a three-dimensional world now, so our units are going to be cubes when we find volume, once we start working with units. So with a rectangular prism, we know that the area of a base is going to be base times height, or length times width. You can think of it either way. And then you multiply that times the height of the prism itself. With a triangular prism, again, it's still just base times height, where the capital B actually means area of base. So we're going to find the area of the triangle using the formula 1/2 base times height, and then multiply that times the height of the entire prism. For a trapezoidal prism, we would find the area of the base, which is a trapezoid, times the height of the entire figure. So we know that the area of a trapezoid's formula is 1/2 times the sum of the bases times height. And we multiply that times the height of the whole thing. So now let's try a couple of examples. In the first one, we have a rectangular prism. So we're going to find the area of a rectangle and multiply it by the height of the whole figure. Now, it doesn't really matter which base you choose with rectangular prisms. In this case, I chose 5 times 4, or my bottom rectangle, to be my base. So I got an area of 20 for my base, and then 6 was my height in that case, because it was connecting my top and bottom rectangles, since I chose those to be my bases. So I got 120 units cubed. In the following example, I have, this is still a rectangular prism, or you could also call it a square prism, because the bases are squares. It's not a cube, however, since all the sides are not congruent. So my two bases are a square, so I'm going to use side squared as my formula for the area of my base, and multiply that by the height of 10. So I end up with 3 squared, which gives me 9. So 9 is the area of one of my bases, and I multiply that by one of my heights, which is 10, and that gives me 90 units cubed. In my next example, I'm told that my base area is 45, which makes the example really easy because I don't have to use my trapezoidal formula. So I'm going to multiply the area of my base times my height. So that's just 45 times 10, which is 450 units cubed. Now in this case, this is tricky on several levels, because first we do have to use our trapezoid formula to work with finding the area of one of our bases, but we're also trying to find the height given that the volume is 12. So we're going to set up, and I didn't write down that the volume was 12, so that's really important information. So this question would say, find the height when the volume is 12. So we put 12 in the place of volume, and then we have our formula, 1/2 the sum of the bases times the height to find the area of the trapezoid times the height of the whole thing. So 1/2 times 2.4 plus 1.6 times 1.2. So these numbers, the 2.4 is the top parallel line in my trapezoid, 1.6 is my bottom parallel line in my trapezoid, 1.2 is my height, the perpendicular distance between those two lines. And apply all that in my calculator, and I get 2.4 h equals 12. I divide both sides by 2.4, and h equals 5. And we're working with meters now. It's just meters because we're looking for the length of a line. For cylinders, cylinders have two bases that are circles instead of polygons. And again, the formula is still the area of the base times the height. So our area of a circle is pi r squared, so it's just pi r squared times the height. So if we look at a few examples here, we're going to substitute in 3 for our height, and we're going to substitute in 20 for the area of our base, since they gave us the area of our base. So that's a nice, easy problem, 60 units cubed. And the next example, they didn't give us the area of the base, so we're actually going to have to work with pi r squared. So we're going to put in 5 in the place of r, 4 in the place of h, and we end up, when we multiply all this out, you just plug in pi times 5 squared times 4 in the calculator, and you get 304.2 units cubed rounded to the nearest tenths. In this picture, the diameter is 8, which means our radius is 4. So all we have to do is plug in 4 in the place of radius and 10 in the place of height. So 4 in the place of radius, 10 in the place of height. Plug it into your calculator. You don't have to use those parentheses. And you get 502.7 units cubed rounded to the nearest tenths. Now, we're going to work with some problems where we leave the answers in terms of pi. So we're told that the volume of this particular cylinder is 12 pi and the radius is 2. And we're asked to find the area and the height. So we're going to set up a problem that volume equals pi r squared times h. We're going to plug in what we know. We know that 12 pi is the volume, and we know that if the radius is 2, we're going to put in 2 and square it to get 4. So now we're going to try to get h by itself, and we do that by dividing by 4 pi on both sides. And when we do that, it's really important that we remember to put in our parentheses for our order of operations. Otherwise, multiplication will happen first. And then when you divide, you get height equals 3. So if the height equals 3, to find the area, we can actually see the area up here in terms of pi. Area is just pi r squared, so it's the radius squared times pi. So that's going to be 4 pi. You can see it here in your problem, or you can just say 2 squared times pi for area. In this case, we're told that the volume is 10 pi and the area is 25 pi. Find the radius and the height. So we start with our formula and put everything in we know. Our volume's 10 pi. Our radius is, or our area is 25 pi, so we put that in the place of pi r squared and write that times height. We're going to divide both sides by 25 pi, and you can actually see how these cancel. It's pretty easy, but you really should have parentheses around them. 25 goes into 100 4 times, so you know the height is 4. And then the radius is going to be the square root of this 25. It's the square root of 25 sitting with the pi, so it has to be 5. And here's how you can do it mathematically. You take the square root of both sides here. Radius is 5. One more problem. Volume is 18 pi. Height is 2. You're going to plug what you know into the formula. So you get 18 pi equals pi r squared times 2. And you divide both sides by 2 pi, or 2. I did it in 2 steps, which you guys do that sometimes. It doesn't matter. I like doing it in 1 step typically. And you end up with radius equals 3. And you can also tell if the radius is 3, you're going to square that and multiply it times pi, so it's going to be 9 pi for the area.